Hello and welcome to the 6th episode of the mathsonlinetuition.com videos going through the C1 book. We're going to try and finish off chapter 2, and we're going to start with where we left off last time, which is quadratic equations. Now, out of all of the methods that are used to solve the quadratic equations is the formula. So we've gone over 2 so far. If you recall, there was factorization, there was completing the square, and now we're on the formula. And from my experience and experience of many other people who have studied numeric degrees at university, is that the formula is by far the most often used. Okay? And actually, the previous 2 methods are precursors or inclusive methods within the formula, so they enable you to carry out this particular protocol. So in the exam, you won't be asked to show how you can go from the quadratic equation to the formula. However, they give it to you here in this book just for your own knowledge. You don't need to memorize it, you don't need to learn it. Perhaps if you're in an exam and you get flustered or frustrated in some way and your mind goes blank and you can't recall the formula, then maybe this is good for you to remember and to learn. But we're going to go straight into an example here. So literally all they've done, just going through the example, is as follows. They've first introduced the equation as 4x squared minus 3x minus 2 equals 0. They've identified their a, which in this case is 4, their b, which is minus 3, and their c, which is minus 2. Okay, and then they've written out the formula: minus b plus minus b squared minus 4ac over 2a. And then literally just inserted the numbers into the formula, which you'll see here. Okay, so use x, here is a, and then what's important for you to appreciate is the way that you should carry out the operations is using the BODMAS or BIDMAS protocol that you've learnt before, but here it's always imperative that you carry out what's in the square root first. So you'll see they had this enormous mess, okay, and they used that approach to resolve it. So BODMAS, BIDMAS, however you've learnt it, and they've ended up with this, and then they again simplified it to 41. Now at this point here, you can appreciate they can't go any further, so they've left the answer in surd form. And remember, again, we mentioned that there are 2 answers here. There's this answer where there's a positive here, and then the answer with the negative here. And you don't need to go any further. And in the exam, this would be absolutely acceptable to leave as an answer in surd form. So as you follow through, you'll see that there's exercises for you to do. And again, let's just take question 10. We'll just go through it very briefly, just the outlines, that is. Question 10. Okay, so 11x squared plus 2x minus 7 equals 0. So what's the steps that we're going to do? So the first step, step A if you like, okay, is identify A, B, and C. Okay, step B is substitute this into the formula, and then carry out the operations. Right, and that's literally it. That's all you need to do to appreciate the answer. Okay, so the next part is sketching the graph, and I want to make a very fine point here. The reason why sketching the graph is introduced this early on in A levels is because it will become the precursor to you recognizing graphs and their features when you go on to other more important aspects of graphs, whether that be calculating and other other areas. In university, your ability to recognize qualities of a graph just by observing it, i.e. visually, is very important, because it will save you a lot of time and it will help you to grasp other concepts that build up from it. So we're just going to go over now 3 simple steps that you need to follow, okay, in order to appreciate how to draw a graph. So let's first of all talk through it, and then we'll make some notes. The first part is deciding on the shape. When A is greater than U, the curve will be a U shape. When A is less than 0, the curve will be an N shape. Again, a U and N is not a rigorously, this is not a technical term. It's just for me to give you the idea of what shape it will look like, and to make it easy for you to appreciate the idea that I'm trying to put across. Number 2 says work out the points where the curve crosses the X and Y axis. Now, we went through this last time in a previous video where we discussed where it's Y is equal to 0 and X is equal to 0. And then finally, probably the most important step that you need to appreciate is number 3, check the general shape of the curve by considering the discriminant. The discriminant is b squared minus 4ac. When specific conditions apply, the general shape of the curve takes these forms. Now you have these forms here. On top, you'll notice that a is greater than 0, and at the bottom, a is less than 0. Okay? Now, when it comes to the different forms, i.e. 2 roots here, equal roots, and no roots here on the x-axis, you have this particular graph to help you appreciate it. So equal roots, b squared equals 4ac, is shown here. Equal roots meaning it touches at one point. Real roots, okay, again you have here, it will give you no real roots, that says no real roots here, so again it doesn't cross the x-axis. And then we've got real roots, which is over here. There's 2 particular points where it crosses the x-axis when it's quadratic. Okay, so just to give you an idea, so if for example we had x squared plus 4x plus 3, then a in this case is 1, which is greater than 0, so we know we're going to have this U shape. Another one we can say is 5x squared plus 3x plus 2. For example, we know that a is going to be 5 here, which is greater than 0, so it gives that U. Okay, how about this particular question? If we said, for example, we had minus 6x plus 3x, okay, plus 1, then a here is minus 6 less than 0, so we're going to have this N shape. And just to make mention of the fact that a can either be more or greater than or less than 0. You can't have a which is equal to 0, in case anyone's wondering why that's not there. Because if a is equal to 0, say for example we have 0 being the coefficient of x squared plus 4x minus 9 equals 0, well then in this particular situation this would cancel out and we're left with a linear equation. Okay, left with the linear equation. Everyone knows linear equation would be a straight line. If you had like a graph here where this was the x and y axis, okay, this is not a representation of this line, it's just an example to show you that a straight line, linear, means that there is no to the power of 2x. Okay, and a good way to remember this, and one way that I've been taught, is draw a table. So draw a table, okay, and then for example here you can put a, and then on top here you can put the discriminant, okay, discriminant, and then you know, essentially all you want to do here is you want to compartmentalize, okay, the different categories, different diagrams that it can occur in. So for example, okay, you can make 3 different columns, alright, and in each case you can put b squared 4ac. You can put here b squared equals 4ac, and b squared is less than 4ac. Alright, and you can have here, right, a is greater than 0 and a is less than 0, and then you can draw the pictures. So here you'll know that this is the case that we have, okay, and here we'll have this particular case, here we'll have this particular case, and again this will help you to categorize all these different types of diagrams, and you can recall them a lot more quickly. Okay, that's the goal here, that's the aim. So let's go down to an example. So you can see they've got example 14, and so what they've done, let's go through the steps again. The first step they've done is identify a. Okay, that's the first one. Is it less than 0, or is it a is greater than 0? It doesn't have to be less than 0 first. You can do whichever way you want. And then number 2, okay, they've identify, okay, the roots, right? And then number 3, again, identify, okay, the disagreement. Alright, so you can see that they've factorized it. Okay, then they've identified the crossing points of the x-axis, and then they've identified the value of the discriminant. And so they say that the b squared is greater than 4ac and a is greater than 0. A is greater than 0, so we know that we're going to get the U shape. They've identified the roots. There's 2 points where it crosses. Okay, so we know we're going to have, okay, 2 real roots. So it's going to look something like this. And then we said that we have the discriminant being, in this particular case, if we go up, it's going to end up looking like this. Okay, actually, rather what I should have done is I should have made like just an indication that it's going to cross at 2 points. Let me correct that. What the more correct way is indicating that there's going to be 2 points crossed, okay, and then completing it by this. Alright, and that's as simple as it is. It's not difficult at all. In this particular question, they've given you an unknown x, alright, and they've asked you to make x the value if you were to have an equal root. Remember, we said an equal root is where b squared equals 4ac, and so this means that you need to adjust your answer for k to give you this particular, okay, this particular equation, this particular equality needs to happen. And so they've said k is equal to plus minus 6. Okay? And so you've got now exercises to do. Again, look, you've got here 3x squared minus 2x minus 5. First you figure out the a, then you identify the roots, okay, and then after that you identify the discriminants, and then you can figure out what form it's going to take. So it's very, very simple. And the thing with mathematics is you just need practice, 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 because the beauty of maths is that there is a particularly correct answer. It's not subjective. It's not a humanities subject, okay, whereby the answer is dependent upon many variables and can be appreciated from different perspectives. Now, there are good things and there are bad things about both types of approaches. For example, in mathematics, if the answer is not correct, i.e. if you've done something wrong in your approach, then the answer will be wrong. But at the same time, if you do get it right, then you know it will be right and you're on the right track. So that means that you just need to practice that right method over and over and over again with these exercises here. And they give you a similar exercise here to that previous example where you have to find k when this has an equal root. And so that comes to the end of that particular subsection and really the end of the chapter, because as you can see we've got mixed exercises you can go through in your own time. And then we have the summary of points, of key points as usual. As we stressed, please do go over this, make sure that you revise them, make sure that you have a book where you note down all these summary of key points, make sure you appreciate them, understand them, go through the videos as many times as you need to understand them and cement them in your mind. If you do not, it will be at your own peril, at your own cost, because as you go on you'll find it more and more difficult to understand and appreciate the chapters. And furthermore, as you go along you'll appreciate that things don't get easier for you. Okay, they'll actually become harder for you, so it's counterproductive to try and avoid doing it in the hopes that you'll make things go quicker by just skipping and moving on faster. Realize that you do things a lot slower when it comes to the calculations and the working out because you have a gap in your knowledge. Okay, so that's it for chapter 2. Thank you very much for listening, and in our next video we'll go over chapter 3 and we'll begin with the following subsections. Thank you and goodbye.